My name is Papoušek. I'm a member of adaptive learning group situated at Masaryk University in Czech Republic. And today I'm going to talk a little bit about evaluation of systems for adaptive practice. We are a small group of computer scientists who develop educational systems. These systems cover a lot of domains from geography to geography, anatomy, elementary mathematics, or Czech grammar. And they are not meant to be used as a standalone educational application because the only content they provide is practice. Yeah? For example, they can be used as a supplementary tool for schools, but not standalone educational resources. The key functionality which is common to them is that the practice is adaptive. The content we provide is personalized to the needs of users, and we believe that the adaptivity makes the learning of their users more efficient. So we are in the situation which is, I think, typical for a lot of developers of online educational systems. We have an online application which is used by a lot of users, and we have to make a lot of decisions. And the question is how to make these decisions and how to evaluate them. And the classic approach or common approach to evaluation is to go to schools, go to classrooms or hire some people and perform offline randomized control trials. It's okay, it's completely valid advice to do it. This method is reliable and it's widely used in a lot of domains, but we are computer scientists, and we have a lot of users in a lot of cases, and we don't want to hire some other people. Probably we don't want to communicate with a lot of people, and doing evaluation offline means it's time-consuming and expensive, and it slows down the development. So this talk is about doing it online, and I will show you some issues which are related to it. So the case study I will show you is about our application for practice of geography. It's online, available to anybody without any registration. You can choose a context for practice, for example, European countries. And the practice itself consists of questions which are multiple choice or open. Here's an example, multiple choice question. And users, of course, can look also at their current knowledge via this card map. The basic architecture of this system, which is again, this architecture is shared within all our systems, is that we have users, quite a large number of users. These users answer questions. These answers are pushed to the system and processed by our predictive model. This model works only with correctness of answers and also with time when they are pushed to the system. On the other side, this model provides predictions for all items available within our system. And when I say item, I mean something like Czech Republic on the map of Europe or city Edinburgh on the map of United Kingdom. So we have prediction of the correct answer in case of open question for the given item, for the given user. And by these predictions, we construct questions by our instructional policy. And these questions are, again, answered by users, and so on and so on. So in the middle is our instructional policy, which tries to be adaptive. And it has two parts. In the first part, we have to select an item to be practiced, and we try to select the item to adaptively to adjust difficulty of the practice. And our goal is here to make user success rate, for example, about 70%. And here is an illustration or histogram of predictions for European countries. So here is prediction, a number of items. You see that European countries are quite easy. There are a lot of items with prediction higher than 80%. And this black line corresponds to our scoring function. And the peak for this scoring function is in 70%. And we can score the items by its score and order them. And you see that because our goal is to have an item with a 70% chance of correct answer, the best candidate is Romania, because its difficulty is around 70%. So in the first part, we have an item, in this case, Romania, and you have to decide whether the question will be open or multiple choice. And in the case of multiple choice questions, we have to select proper destructors. And in our system, we select destructors based on data from wrong answers on open questions. And in case of Romania, when your answer is wrong, there is a 25% chance that it's Bulgaria, 10% chance it's Ukraine, and so on. So probably Bulgaria, Ukraine are good candidates to be destructors. So it's the main idea of the adaptivity in our system. And the question is it beneficial to our users when we do this kind of stuff? And by beneficial, I mean whether they learn more and whether they are motivating to use the system, to stay within the system and doing the practice. So learning and engagement. We performed online A/B experiment where we assigned new users to one of 4 conditions. The first condition stands for our adaptive algorithm, adaptive item selection, and adaptive destructors. The last condition is completely random one, random item selection, random destructors. And the second one and the third one is partially adaptive, random destructors or random item selection. Experiment was running from August to October 2015, and we collected more than 1 million answers. And these answers were mostly from users coming from Czech Republic and Slovakia, because we are from Czech Republic, so it's sure. One note, we collected so-called reference answers. I will explain it later on, but reference answers are answers on reference questions, and these questions are every 1st, 11th, 21st, and so on, and are open and random. And we do it per user and context. That means that if you start practicing European countries, we ask you for a reference question. 11th, again, will be a reference question, and so on. If you switch the practice, we again start with the reference question. If you switch back, we continue. And by this, we try to avoid bias introduced by our item selection, instruction policy. Let's describe, here's an example of a reference question. Here we ask for Greece. This item is chosen randomly, and the user has to choose within all items available within context of European countries by clicking on the map. Let's describe the data. Conditions differ in their difficulty quite a lot. Here we have number of answers, and on vertical axis, average error rate. So these curves correspond to evolving error rate during the practice. And these peaks here are related to reference answers or questions, because these questions are much more difficult than the rest of the practice because they are random. You see that if you forget about reference questions, our version of algorithm, the blue one, is almost constant, and the random condition is the easiest one. And of course, it has. We think that it has an impact on further analysis. Okay, let's look at the analysis, and let's start with engagement. For engagement, we collect users' feedback. So after 30 questions, we ask you to evaluate your practice, whether it's too difficult, too easy, or appropriate, plus minus. And based on this data, we can compare the conditions from adaptive to random. And based on this, maybe the most interesting is percentage of users who say that the practice is appropriate, green bars. And in this case, our adaptive version is the best. Interesting observation, or not so surprising, but it's good that the random condition has the highest percentage of too easy records. So it's related to our previous observation that it's the easiest condition. So users can observe it. The second viewpoint is survival. On horizontal axis, you have a number of answers again. On the vertical one, percentage of users having at least the given number of answers. So it gives us a survivor curve. These drops are related to our system, because the system presents questions in sets of 10, of size 10, and after 10 questions we present user a summary, so it's natural point of leaving. So it's not so surprising. And when we have a survivor curve, we can compare it. So the highlighted one is our fully adaptive version. When I compare it to adaptive random one, in the beginning, in short time engagement, there is no big difference. It's surprising, but later on during the practice, the difference appears. On the other side, when item selection is randomized, difference is within a short time engagement, and later on there is no difference. And fully random practice is the worst one. The last viewpoint on engagement is percentage of returning users. In our case, this percentage is quite low, but despite this fact, we can observe differences among conditions. And again, our adaptive condition or version of the system is the best. And it's good news because we think that it's related to a long-term engagement. Learning. In case of learning, the situation is much more difficult because data we analyzed are highly biased by instructional policy we analyzed or we compare. This issue is quite complex, but I give you at least a simple example. Again, here is an average error rate, and we see that random condition has the lowest error rate, but it doesn't mean that it's the best in learning. Yeah, and this error rate, average error rate, also influences our model, which tries to predict users' knowledge. So it's really hard to if you forget about these peaks, these reference answers, it's hard to compare the conditions. So as I already described, we use reference answers. We group first reference answers, second, third, and so on together. For each group, we compute an average error rate, and it gives us a learning curve. On the horizontal axis, now we don't have answers, but reference answers. On the vertical one, an average error rate. The filled area, which is not so obvious to see, corresponds to 95% confidence interval. And again, we can compare conditions. Adaptive random condition is worse than adaptive one. On the other side, there is no big difference between our fully adaptive version and random adaptive one. And again, random is worse. These data are raw. We can fit it by some standard functions. In case of learning curves, it's typical to use power law. It gives us a smooth learning curve, and you see that there is no difference between random and adaptive random, and no difference between random adaptive and adaptive. In extreme or more advanced case, it would be beneficial to compare not these curves, but only some parameter, for example, learning rate. Yeah. Learning curves are cool, and it seems to be it's working, but there are some issues which has to be taken into account. And the biggest issue is related to attrition bias. The first point of the learning curve is computed for all users, because all users in our system have at least one answer, and this answer is reference one. On the other side, for example, when I look at the fourth point of the learning curve, here I have only 50% of users. And the second tricky part is that these 50% of these users can be different among different conditions. And in our case, we found out that prior knowledge of survived users varies among conditions. And to be more specific, here is a graph where on horizontal axis there is a number of reference answers, and on the vertical one is an average error rate on the first answer for users having more than the given number of reference answers. So for example, in this case, here I have users having more than 4 reference answers, and these users, in case of random adaptive condition, have about 50% error rate on the first answer. But when you look at similar group of users in case of adaptive random condition, these users have error rate about, I don't know, 57%. So when I compare learning curves between random adaptive condition and adaptive random condition, I compare different learning curves for different kinds of users. For random adaptive condition, I have users with high prior knowledge. In case of adaptive random condition, I have users with low prior knowledge. So this has to be taken into account when I interpret the results shown here. The second issue is related to time. Our system is for factual knowledge, and factual knowledge is related to spacing effect, forgetting effect, and so on. So time is important. And on these graphs, I have no time. In our case, the most of users practice only within one session, so we can simplify our assumptions. There is no time because these sessions are short. But in more complex applications, it would be, I think, beneficial to introduce the third dimension. Here we have an average error rate. On this axis, reference answers. And we think that it would be beneficial to introduce the third dimension, the time since the last reference answer. So in this direction, the knowledge increases. In this direction, knowledge decreases. Increases, decreases. But to compare learning surfaces, we don't have enough data because our users are mostly users who practice within one session. Yeah, that's almost the end. To conclude my talk, I'd like to emphasize that in case of online educational systems, there are important two things: learning, because they are educational, and engagement, because the system is on the internet and users can quit when they want. It's interesting that in case of engagement, there is a research evaluating engagement in online environment. For example, looking at number of interactions. On the other side, in case of learning, the studies are mostly doing offline evaluation. To measure engagement, it's a good idea to collect feedback from users. In our case, it was beneficial and reliable. On the other side, when you want to distinguish between short-term and long-term engagement, survivor curves would be good tool, or are good tools. And of course, it's natural to use also a percentage of returning users, which is also again related to long-term engagement. Learning is much more difficult. We think that it's necessary to collect data which is not biased by your instructional policy. In our case, we collected randomized data which we call reference answers. And using this kind of data, you can construct learning curves. But be aware that there is an attrition bias, which can which can complicate the things a lot. So thank you for your attention. Here is again a link to our system, a link to data we collected within our experiment, and of course contact me. Thank you.
Okay.
Yeah.
Repeat the question.
Uh-huh.
You said that after 10 questions you give some feedback. What kind of feedback are you giving to people who are using the system?
Okay, so the question is what kind of feedback we collect after 30 questions, not 10 questions. The feedback is we show a dialogue with a question. What's the difficulty of the practice? How do you feel about it? And a user can choose whether it's too difficult, appropriate, or easy.
So it's a questionnaire.
Yeah, it's questionnaire. Yeah.
Asking for feedback.
Yeah,
so
yeah.
Me, if I engage in these tasks,
Uh-huh.
do I have some feedback for myself?
For yourself, the only thing sorry, I didn't get the question. Yeah, after 10 questions, we provide a user with feedback about her success rate and the items which were practiced. So she can look at, I practiced, for example, Greece, and the question was correct. Or sorry, the answer was correct. Yeah, sorry.
I have a question about one of the slides of your results, the one in between
drops
You
here.
can see the number of the slide. I think it's the one.
Oh, sorry, survival, learning, engage. This one?
I think it's the one before this one. The one with the bars. No, a bit before. No. Before. That is one. So I was expecting that the more random the condition, the more students would give feedback of things being too easy or too difficult, and the more adapted, the more they would feel things are appropriate. And that's kind of what you see with the easy question. So the more random the condition, the more people say this is easy, as you mentioned. But on the difficult side,
There is no difference.
it seems to be constant. Do you have any comment about that?
Yeah, it's a great question. So the question is why there is no difference in too difficult percentage, and the only difference is in too easy percentage. So the reason is that the most of data we collect is from European countries, and this, it's about 20 or 25% of our data, and this context is really easy for our users. Yeah. So if we present a fully random practice, it means that instead of Serbia or I don't know another country, I will ask for Russia, United Kingdom, France. So there is a high chance that I ask for an item which is easy.
Okay, thank you.
Any more questions?
So at some point, I lost track of which of the A's was adaptive distractors versus adaptive questioning. Was the efficacy higher as measured by error rate for adaptive distractors or for adaptive?
Once again, please. I didn't get it, sorry.
So which variable had the highest efficacy? So which one, as measured by error rate, which was the more successful changed variable? So was it adaptive distractors?
More successful variable. Yeah, I think it's the question is whether which part has the bigger impact on engagement or learning or
well, learning as measured in your case
error
by
rate.
Error rate.
Yeah. Yeah. So it seems that the first part, item selection of item which will be actually practiced, is more important with respect to learning. Yeah. The second part, how many distractors or which distractors are presented, is not important. On the other hand, when I look at the engagement, there is a difference. Yeah. The first, item selection, adaptive item selection, is important in case of short-term engagement, and adaptivity in distractors is important in later on during the practice.
Appreciate it. Thanks for clarifying.
Great. Okay. So if you have any more questions, follow up later. Thank you once again for being here.